Fred here, AF Math and Engineering. Today we're going to do a quick video for you on the linear gradient in engineering economics. A linear gradient is when you have a linearly increasing, it can either be a series of deposits or a series of payments, but it's increasing at a rate that is linear, so it is not increasing exponentially or anything like that. So that's what we're going to deal with today, and this question also is going to deal secondarily how to break up a cash flow diagram into two parts and treat it as two sets of different cash flows. So two lessons to take away from this video. Let's go ahead and let's get started. So I just wrote the question out here, and it's a fairly long question, but this is fairly common in this course. So you need to be able to read the question and take the information out of it, because the question's not that hard, but sometimes you can get lost. So let's read the question. So Jane's company purchased a new truck with a 5-year lifespan. The company wants to make a single deposit today into an account at 12% to cover all maintenance costs. Maintenance on the truck costs $1,000 after year one and increased by $250 every year for the lifespan of the truck. How much should Jane deposit into the account today? So the first thing we need to do is translate exactly what is on the paper here in the question into a cash flow diagram. That's our first step always. Let's just write down what we're given here. So we're given I. I in this case is 12%. Okay, and the number of years is 5. 5-year lifespan on the truck. Let's go ahead and get started with the cash flow diagram. So, Jane's company wants to make a payment right now. We'll call that P in year 0, okay, to cover 5 years of maintenance costs. So it says in the first year here, the costs after the first year, so at the end of first year, are $1,000. Okay, so we're going to write it like this. That's year 1, and it says that after year 1, they increase by $250 for the lifespan of the truck. So that means that in year 2, it's going to increase to $1,250. Year 3, okay, is going to be $1,500. Year 4 is going to be $1,750. And year 5 is finally going to be $2,000. Okay. So that's what we've done is we've taken the question, the worded question, we've transferred it into a series of payments on a cash flow diagram. So the next step, okay, is to take a look at this and determine a plan. Okay, so what do we need to do? What is the question asking us for, and how do we get there? So the question's asking us for the value of P. So what value of P is equivalent to this series of payments here? So, well, what we can do here, and I'm going to show you a trick, is you can break this down into two different cash flow diagrams. Because if you go like this, and I'm just going to cut this diagram here, okay, if I shade this region in here, what we have is we have an equal series payment, right? We have an annuity of $1,000 every year, right? So let's go over here. This can be transferred into two different cash flow diagrams. Okay, so this is number 1. Okay, so what we've done is we've taken these thousands out of this, but we still have the increasing 250. So we also need to make a cash flow diagram for that. So as you can see, we've taken the 1,000 out in year 1, so it's 0 in year 1. Okay, nothing happens. Year 2, we're going to have, this is part of the gradient now. Okay, so this increase here that is linear is known as our linear gradient, so that's 500. Okay, so now what we've done is we've broken it down. We'll call this P1 and we'll call this P2. Okay, so what we've done is we've broken down this series of payments into an equal series payment and a linear gradient. And why we've done this is so that we can go to the tables and we can use the table values and really speed up the question. Because you could you could do P given F for each value as well, but this is a little bit faster. So let's try it this way. And this is a good way to practice and get a good understanding of cash flow diagrams. So if you take a look on the screen, okay, what I've done is I put up the formula for what's known as a, and we did a video on this before, but an equal payment series. Okay, and what we're looking for is we're looking for P, and we're given A, right? And if you take a look on the right here with the little arrows, you have P and then all the A's. As we can see, the A's start 1 year after P, okay, which is what we have in our question here for the for P1. And what is our n? Well, our n is 5, so we go 1, 2, 3, 4, 5. So I'm going to come down here. Okay, P is going to be equal to, I'm going to say P1 plus P2, okay, because we broke them down into two separate payments. Therefore, P is equal to, okay, we're going to do P1 first. Okay, so P1 is going to be 1,000, okay, because we're doing, that's the value of A, okay, and we're going to look for the factor that gives us P given A with an interest rate of 12% with 5 periods, okay? And if we go, and I'm going to put the table up on the screen there for you, okay? If we go over to the P given A and we go to n equals 5, okay, we're going to get a value, this value here is equal to, on the table, 3.6048, okay? So that's the first cash flow diagram broken down for you. There we go. Now let's take a look at the second payment, P2, and this is where our linear gradient comes into play. Okay, so our linear gradient here, we have nothing in year 1, and then we have year 2, 250, and it's increasing by 250, so 500, 750, 1,000. So if we go ahead and take a look at the formula sheet again, what you're going to see is we have a linear gradient formula here. You don't need to use the formula, we're going to use the table. But the most important thing to look at is the diagram here. Okay, so the diagram, what we have is we have a payment in year 0, and then in year 1 you see there is nothing in year 1. So what I've discussed before in this course is that you need to follow the way the formulas are derived in terms of how it's laid out in the cash flow diagram. So you need to start on the cash flow diagram at the right spot. All right, and in this case we are starting on the right spot, because going back to the page now, if you'll see, we have P at year 0, we have nothing in year 1, and it's increasing, right? So it's increasing like this, linearly. And that matches exactly the little diagram on the formula sheet. So pay attention to that. So that means, what that means is that we can directly apply the interest tables in order to solve this, P2. So P2, okay, what is our G, right? Well, we're first going to look for our P given G, okay? On the interest table, we have a G value here of 250, okay, because it's increasing at a linear rate of 250. And we are going to look for P given G, I, which is 12%, and N, which is 5. Okay, so we have 1, 2, 3, 4, 5 periods. This is simply going to be 6.3970. Very good. So if we just go ahead and plug these values in, okay, so we're going to say that P equals P1 plus P2, okay, equals 1,000 times 3.6048. So we have 3604.8 plus P2, which is going to be 250 times 6.397. That's going to give us 1599.25. And that means that P is equal to $5,204.05. So that is how much that Jane's company, or Jane, must deposit into her account today in order to cover all the maintenance costs throughout the lifetime of the truck. Hopefully you learned something from that, how to break up a cash flow diagram into two separate ones, and how to use the tables in order to solve it. Thanks for watching, like and subscribe.